Hello everyone. So our next speaker is Suresh. He leads IT quality at International Motors with over 27 years of experience driving enterprise-wide quality transformation. He is currently also leading the implementation of AI in testing at International Motors to improve test efficiency, scalability, and innovation. Suresh is recognized for building high-performing quality ecosystems that align technology, process, and people with business objectives. So we will welcome Suresh for today afternoon session.
Yeah, thank you very much. So, uh, good afternoon, everyone. I'm going to speak on introduction to test maturity model for AI in testing. So, currently, like we have got test maturity models with respect to regular testing or software quality assurance. So, what I looked at it as when organization are mentioning we are using AI, we're in testing and all. So, there is no prescribed measurement model or maturity model which says in what level they are in. So that was my main preface of coming out of this model. Like we have seen multiple multiple groups presenting this, but we are making sure from my side is what is the level they are trying to project in. About me, my name is Suresh Krishnaiah. I work at International Motors leading the quality assurance. And here is my LinkedIn contact. So let me delve into the agenda. So what the agenda today is why test maturity model really matters in AI. What are the key characteristics and levels? What are the benefits? And also a small snippet is where in software test lifecycle we can include this artificial intelligence in testing. And many were curious enough, like, and if I want to have AI, what can be the readiness checklist? So that's the overall agenda. And now dwelling into the model, why test maturity model really matters in artificial intelligence or AI. So this started like probably in 2024 around the US Department of Commerce, the NIST. They presented this framework. So what really they showed was in terms of the AI risk management framework, we need to have three main components to mapping, measuring, and manage, with central is the governance system. So this all three I was looking at as a factor in the AI test maturity model, and how we can do the measurement and manage and provide a guidance, a roadmap to achieve from lower level test maturity in AI to high level test maturity. In fact, test maturity models matter in AI because AI failures are not just the software defects. It goes above and beyond that. They can come in the data quality, the bias, drift, or even the weak prompts, poor monitoring, and gaps in human oversight. A perfect or a good maturity model gives teams a structured way to move from ad hoc testing to repeatable, risk based, and measurable assurances. The NIST's AI guidance explicitly highlights the importance of testing, evaluation, verification, validation, which we call commonly as TEVV, throughout the AI lifecycle, not just at the release or implementation, what we usually do the test execution level. So this is why it says why AI matters. Test maturity models in AI matters most. Just to summarize, is in traditional software, test maturity improves the quality assurance quality part of it. In AI, test maturity, along with improving the quality, it protects quality, trust, compliance, and business safety, which are key critical components in current industry terms. So why just delving just one more thing is with this test maturity models, right? It helps organizations to assess where they currently stand when the multiple companies say like, and we are implemented AI. It kind of provides them a framework of using this framework. Where do they stand? And it introduces a new class of quality and business risk that cannot be managed with the traditional testing approaches alone. The test maturity model, what I'm going to showcase, provides a structure needed to build confidence in AI outcomes, support governance expectations, and also reduce operation and reputational exposure, which is very, very much important currently. uh, Test maturity models matter because it also, the AI failures are, as I said, it's not just a software defects, it across the board, what we are looking at. So now coming into the progression, my approach was a simple way, just like TMMI at the test maturity model, from the ad hoc repeatable. So I was looking at, when if you're doing just the manual testing alone, then we progress to structured automation, data driven quality, AI assist testing, and then we delve into the automated quality engineering. This series of progression, which will also show an organization which maturity model they are in. So that's what is the main preface for me to build this test maturity model. So, if, with respect to the outcomes, uh, this test maturity model makes AI quality a systematic instead of the isolated test efforts. The teams define standard process for model evaluation, and the way TMMS specifically is designed to improve test process in a structured stage way. This also includes AI to be part of this journey. One important factor what I always stress is this test maturity model also helps in improving the test and governance part of it, which is key critical component in this journey. And the next one is it reduces the business risk. When we say business risk is, for example, the low maturity the AI testing organization always or often they do the check, like in if it really works, if what we are building does really works. But this high maturity AI testing organization will also, along with how does it work, they also say when does it fail, for whom, under what conditions it failed, and one of the couple of things is how will we be able to detect in production, or if it's post production, what was the reason it failed. So all those things will be part of this business risk. And as I said previously when I was in the ignite session, this is very, very critical for hallucinations, the bias, robustness, security, and model drift. All these are very important component of it. In fact, the NIST's newer AI testing work also stresses understanding both technical and socio-technical impacts of the implementation. And next is it supports scaling from a level 2 or level 3, how it helps you to scale across the organization, not just one department or one group. And it also gives the leadership a measurable control. Uh, if it's in level 2 or level 3, when which I'm going to show, we may not be able to do the measuring things, and here we are going to implement some of the measurable techniques or the metrics. Using that, where we will be able to evaluate and look at the data part of it, and then see what can be the next step of implementation, next step of governance, or next step of quality. So with that in place, let me take you to the next next test maturity model, what I have defined or what I have collected so far. This AI test maturity model has 5 levels, starting from level 1 to level 5. The test maturity models also provides a structured view of how an organization testing capability evolves over time, and it helps to measure the current state of quality practices and provides a roadmap moving from manual to heroic testing towards intelligent, data driven, and autonomous quality engineering. Each level, what I have stressed is reflecting the increase in maturity process, along with test automation, data usage, governance, and also the business alignment part of it. And this maturity model takes a journey from manual fragmented testing to the autonomous intelligence driven quality engineering. So when you look at it, the level 1 is mainly the manual or reactive testing, and level 2 is the automation. Level 3 is the data enabled quality. Level 4, which we call it as quantitative managed, or what I call as AI augmented testing, is AI enhanced automation. And level 5 is optimizing, which I can say is one of the way of autonomous quality assurance built using the continuous intelligence, how it improves by itself and helps to stay ahead with respect to the competitors and also the new way of challenges what is going to come. So, in the next 5 to 8 minutes, what I'm going to do is I'm going to explain to you what each test levels mean, and then to you do that, what are the smaller improvements what an organization can implement. So coming to level one, what I call as initial, here the testing is largely manual, inconsistent, and dependent on individual effort across applications. Many a times in some of the organization, what you can see, there will be some test managers or test leaders who in their group will be able to show maximum amount of improvement just for their group only because of the heroics or the way they implement, not from the process but their way of working style. So that processes will not be standardized, or tools will be more and more fragmented, and then with minimal reuse capability. And in some cases, the testing is often performed late in the cycle, leading to reactive defect detection or very higher delivery risks. So if you look at the organization, this may be the common traits what we can see. Although AI is used, but AI is used in pockets, not across the board. The defect detection in this case is more of a reactive process. An organization like this, if it is, the immediate action what I recommend is try to make sure a common central test repository is established where all your test assets is used, only all the tests like test cases and defects and everything is in the common test repository. And you try to define basic test documentation standards and templates which may be customized to each group but it's implemented across the organization. And also make sure a standard defect logging practices is implemented, not with some in Excel, some in SharePoint like that, just one central test repository. You start capturing and and also making sure the historical test results are in one structured place where you can review and refer to the previously if you want to go for next level of improvement. And I always stress the fact, if you're going to the next level, if you're going to implement AI, test coverage practice is one very, very important thing. That is where it assures the business that uh, we, whatever business wanting to implement has been validated and it's ready for production. And that is not a manual work, it should be an automated way through the central repository. So you should be able to easily pull the report and share it to them. So these are the common immediate actions what I step if you want to move from level 1 to level 2. The next one is AI test maturity level 2, which we also call it as managed level, where a good amount of automation practice is established. To me, if you're a level 2 organization, a test design with AI practice is established. So a good amount of time is saved, and then you still will be able to move forward with the next level of improvements. The test automation is in place, and my assessment or so far with my experience is at least on a minimal 50 to 70% of the test case regression coverage is completed. You have a partial test data structure, the script version control is there, and repeatable execution processes are implemented. And I also what would like to say is that there will be a very good improved traceability or test coverage between the tests and defects. Looking at the defects, you should be able to identify which user story or requirement cost was linking to it, and also which test case was the main cause for it. So you should be able to look at the two-way traceability between these two. That's one of the key characteristics part of it. And if you want to be in level 2 or moving to the next level, following is what I strongly propose. Since you are implementing automation, try to make sure a standard test automation tool is implemented and a test central repository tool is implemented. I've just given an example, and based on your needs and organization needs, you can take care of it. And the next one is making sure a common standardized test naming, tagging, and the folder structure is there, because test case cataloging is very very much important in this level, where look, the reusability comes into picture, and the teams do not start writing test cases as and when they see the requirement. They'll be able to look at the existing test case or reuse the existing ones. So those are the different mechanisms. We'll be able to see a difference between the level 1 and level 2. And when you're doing the automation, make sure a common exit and entry criteria is present. And also with your automation scripting, a very robust version control is being present there. So these are the key characteristics what I would like to call for the level 2, which is the managed one. And level 3 is mainly in the defined level, where it's also, I also would like to call it as data driven quality assurance. In this one, testing becomes standardized across teams with a very clear governance, defined metrics, and integrated reporting. Why I will say reporting is, here is where once you implement, you should be able to, the reports you should be able to verify and validate if whatever you had implemented is being done properly, and then use those data for the next level of improvement. The test data, execution outcomes, and defect trends are consolidated into dashboard, what I previously called as reporting. And then it also enables the proactive decision making. So here you're more looking at the data driven. Your decisions are based on the data what is being presented to you from the executions of the actions what has been implemented. And your decision and your reporting will be of better quality, and the organization will be able to get a clear view of how the overall organization quality is being implemented, not just from the testing alone. Some of the key characteristics is that the test automation is integrated with CI/CD. So the continuous implementation, continuous deployment is continuous integration and continuous deployment is there, and historical defect trends are tracked, and also the test coverages metrics are measured. And through your centralized dashboard, business will be able to take a look at it and take a decision if we can move your assets to uh, any of the features to production or what they can do. And for the audit purpose, which is one of the key component, you should be able to, the reports will serve as the means for the any of the audit requirement needs. So that is some of the key characteristics what for the level 3 and in the data driven. So one important other thing what I would like to say is, if we have to in the level 3 organization, level 3 steps is the immediate quality analytics dashboard implementation, making sure your data sets are labeled and it will be used accordingly. You define enterprise quality assurance metrics, not just a group or your business unit alone, and establish a key critical governance review, which helps to make sure you're improving as time comes and you're not becoming stale with just the same reports. And one key critical difference, what I'd say is, you should be able to align your test reporting to business risk and release readiness. That's way a level 3 organization looking at the data driven quality QA will be able to take decision and move forward. And here the quality decisions become increasingly data driven and proactive. So that's the one of the important thing. And test execution, defects, and test coverage data are all unified in the dashboard, not just the test execution or test coverage data alone. Coming to level 4. In level 4, what I'd like to call it as, it's a quantitatively managed or AI augmented testing. The use of AI, implementation of AI will be more and more dominant here. And in this way, the AI, you're going to use the AI assisted capabilities. Why I'd like to say in level 4 more is, by the time you would have started to use AI in a matured way, and your security and other components are being implemented, so you'll be more confident in leveraging AI assisted capabilities in more decision making and using across the board. The AI helps prioritizes in this case, the AI helps prioritize tests, identify risk areas, or generate test ideas, improve automation resilience. So all these things are very, very important component of it. And you should be able to optimize regression scope based on the test data and the business impact alone. So these are the major thing. What I would like to say is level 4. And one of the key characteristics here is the predictive defect analysis. So more than defect detection, you're looking at the defect prediction part of it. And the NLP driven test generation or risk based prioritization is there. And your scripts are used in self-healing scripts, where if any component is being changed, you don't have to re-script the whole thing. So the self-healing mechanism, which is part of the AI automation, you should be able to move forward and go with the additional scripting. So these are the key important characteristics. And some of the immediate actions, what I'd like to say is, the organization starts using more of the AI capable tools such as Tosca AI or Mabel, which I've seen in the past, which has been implemented. And you define AI usage policies across the organization. And there will be a lot of pilot AI assisted test design or self-healing automation in a few areas where you should be able to improvise and then start implementing with the newer methodologies available. Finally, with the level 5. Here, what I'd like to call as optimized test maturity model or autonomous QA. Why I call it as autonomous QA is, here you're leveraging autonomous agents to execute, analyze, and learn from test outcomes. The continuous intelligent enables adaptive adaptive closed loop quality improvement, and quality here is embedded into delivery with faster feedback and lower risk. Here, you focus mostly on the integrated digital twins, feedback loops, and AI drift monitoring. So, what do you mean by the autonomous QA is, where QA becomes deeply embedded into delivery, enabling faster releases, lower risk, and continuous assurance. So, business or development should be able to deploy in a faster life cycle, because you're leveraging AI into more and more decision making with less of the human interventions. But still, I propose a human oversight on the overall system. The ecosystem where autonomous agents can be used are in the execution, design, analyze, and adapt, and learn from the outcomes. So these are the major things what I'd like to say from the AI way. And when I mentioned digital twin, is in digital twin integration, the closed loop feedbacks, continuous learning will be from production as well as the test outcomes. So these two are the two feeders for the digital twin integration for this level 5. And some of the immediate action is, you integrate with digital twin systems, implement AI model drift monitoring, they establish autonomous feedback loop, and define enterprise controls for AI reliability, compliance, and ethics. Finally, your model will be refining as and when time comes, based on the business outcomes. So, this maturity model provides a practical roadmap to evolve an organization from manual testing to AI enabled and autonomous quality engineering through stronger process, automation, data, and governance foundations. So, these are the 5 levels what I would like to present. And overall, just in a snapshot, I wanted to showcase to you how the level 1 to level 5 goes, what are the different stages, what are the descriptions, key characteristics, and what can be the immediate action as a summary if someone would like to take a look at it in one shot. So finally, in summary, what I'd let's say is, like, if you look at this right from the manual fragmented testing in level 1, it's moved to the more of the autonomous intelligence driven quality engineering, which helps to move the test maturity from the ad hoc to an optimized or autonomous QA model. So the benefits, if we want to talk, is the AI introduces a different risk profile than traditional software. That means you're just not using a test like the regular testing. Here you're leveraging AI into more and more into your way of life. And test maturity is what turns AI from an experimentation model to an enterprise capability. You're leveraging the features of it more into the enterprise capability. And finally, this to me is a governance and business risk opportunity, not just for the testing, just as a testing alone. Like when people call for testing, I would like to call it an organization implementation across the board. There are a couple of slides I would like to showcase. The next one is where AI can be implemented in quality assurance if across the software test lifecycle. So I just gave us few examples where I have seen it can be implemented, and also your transition journey from the level 1 to level 5, where requirement analysis you can use the NLP, natural language test creation, and test design. You should be able to leverage any of the test case generation tools, and test automation, like self-healing test scripts in a test automation. And test execution, you can start using AI driven test optimization or autonomous test agents. Just taking a look at how the code changes, it starts implementing execution only those components which impact the code change. And in the post production is how you can predictive defect analysis or root cause and impact analysis. All those things can be implemented. With respect to AI test maturity model, like as a summary I said is this maturity model. What I have implemented is it provides a practical roadmap for an organization to evolve from manual to AI-enabled autonomous quality engineering through a robust and strong process, automation, data, and governance foundation. And this, as a for summary, you say, like with respect to this implementation, the benefits is clear enterprise roadmap for transformation, improves release speed and efficiency, strengthens governance, standardization, and data-driven decision making. And finally, what we all look at after the implementation is lowers the overall cost of quality, which is very, very key important component, while building a scalable foundation for continuous improvement and future autonomous QA. So these are the main, what I would like to say is the business benefits of implementing AI maturity model. Um, and if your organization is planning to implement AI, and I always would like to say and stress is first start with AA readiness checklist, and this is a simple checklist what I had made, and try to see where we stand from the organization and what we have implemented. If you have this is self-assessment, you can easily do it, and accordingly you can take a call like where you want to start from the next process. And with respect to assessment process, what I provide is a dimension, and what can be the assessment focus for you, and what can be the maturity target which you can start leveraging it from the AI readiness checklist. Once it's done, this is based on my experience, my understanding is if you want to move from phase 0 to phase 1 or phase 1 to phase 2, this is the standard time what you would like to put as part of your roadmap. And what should be the focus and what can be the outcomes is what I wanted to showcase to you. In the event of time, what I would like to end is with respect to AI test maturity benefits for organization that treat AI test maturity as a governance and risk priority will be better positioned to scale AI with confidence, control, and trust. This I've seen practically in multiple places. Otherwise, what will happen is there are many instances what I've seen from past 3 to 4 years. I implemented AI and we failed, or like it worked for some time. We did not know what to do, and there may be sometimes the way the whole QA organization disbanded or outsourced in multiple ways. So what I'd like to say is it should be a journey with the overall IT and business together. And when you treat AI test maturity as a governance and risk priority, you'll be able to take a better decision and move forward to the higher maturity models. So that ends my session. Thank you.
Thank you. Thanks a lot, Suresh. It was a wonderful presentation. We will quickly jump into the question and answers since we have like 1 minute left. So we will just cover a few questions. Looking 3 to 5 years ahead, what governance shift will leaders need as AI testing evolves from validation checkpoints to a fully autonomous, trustworthy ecosystem?
So where I would like to say is when using the AI, where people will from the governance shift is looking at the data as more, and here you have to take a percentage of AI data, AI results as part of the decision making. I still say human validation or human decision is very, very much important. The AI input can be used as a catalyst or your in your decision making, but not 100%. Many of the people say that, look, I started using AI, so I leverage AI decisions for the next level of maturity. I strongly suggest that's not the case. You still need to have the human decision making in this.
Okay. Thank you. Thanks a lot, Suresh. This presentation was very valuable, and thank you for your valuable inputs.
Okay, thank you very much.
Thank you all.
Thank you.